Okay, so we have this demonstration here of a pure alpha source, a polonium 210 source of 0.1 microcurie strength. And I have it on top of this pancake probe here going to my Geiger counter. And I have it connected to this frequency counter, which is set to a gate time of 10 seconds at present. So I have a depth gauge here that I can use to change the height of the sample above the detector, and I can also then accurately measure that distance. Right now it's about ½ an inch above the surface of the detector, but we're getting essentially background counts because I have this piece of cardstock in between the alpha particle source and the detector. We're getting about ½ a hertz for the count. It's varying between about 0.35 and 0.6 hertz. And that's pretty much what I've been measuring for background even without the sample present there. So let me take the card away here, and you can see that through that ½ an inch of air there, we're getting quite a bit more counts, getting about 70 counts per second. We'll let it go for another 10 seconds and see what it says, just so we get a better idea. 76 counts per second. Now let me let this go almost all the way down. We'll let it go essentially all the way down there. So now it's resting against the protective mesh on the top of the detector. And now we've gone up to 381 counts per second. Let's let it count again to get another measurement. 380 counts per second. So you can see even that ½ an inch of air cuts it down by a factor of 5 approximately. So let's raise it up again a little bit. Okay, so now we're about 330 thousandths of an inch above the surface, a 0.33 inch, and we're reading about 200 counts per second. Yeah, 208.7. So now let's put a regular piece of paper in there. That's regular laser printer paper or copier paper. And that, I measured it at a thickness of 100 microns for that piece of paper. And now that cuts it down to about 12 hertz. So certainly still higher than background. We'll let it count a little bit more to get another measurement. Oh no, actually it's quite a bit less. So 0.7 hertz. I'll wait again to count another 10 seconds to get another measurement. Yeah, 0.745. So now it's only slightly higher than background for that piece of paper. Okay. Now let's try a piece of mylar plastic that is 50 microns thick. And we'll have to wait for this to count twice because the first 10-second period will have been include part of the time when the plastic wasn't there. .76 hertz. So this is about the same. This 50 microns of mylar plastic is gives about the same amount of alpha shielding as the the 100 micron thick piece of paper. Actually, now that 10-second interval, it was only, there were only 4 counts, so 0.4 hertz, okay, there, 1 hertz. And if we put a second layer of this mylar in there, it should cut it down even further. We'll have to wait. Let's see here. 0.65, but let's wait another 10 seconds to be sure that the entire 10-second interval was measured with the 2 sheets of mylar in there. Yeah, 0.43. We'll go for one more here. Really, for this low account rate, I should be using a much longer gate time. 566. Okay, now see, last data point here, I have this Kim wipe, which is very, very thin paper. I don't know the exact thickness, but the entire sheet, this entire sheet here, which is 11 by 21 centimeters, weighs less than half a gram, 485 milligrams. So that's about 2.1 milligrams per square centimeter. Let's put this in there now. Just one layer of this. Okay, so you can see that's not nearly as good at shielding, but it still cuts it down substantially. .6 hertz. Hertz. So even this extremely thin piece has very, very substantial shielding. Let's go back, let's double this up and see what we get. .1 hertz. .2 hertz. .4 hertz. So, yeah, substantial. Not as good as the mylar or the thicker paper, but still very substantial. So if you compare that to human skin, the human skin has the very topmost layer, called the stratum corneum, is made of cells that are not entirely inactive, but they have no nucleus and no organelles. At least based on what I've read, and that's between 10 and 40 microns thick. So you can see that that would stop the majority of the alpha particles. The entire epidermis, which definitely does contain some living cells, is 500 microns thick. But that's also very resistant to radiation damage because that's what gets exposed to ultraviolet light a lot. And so clearly that would stop essentially all alpha particles.